Hi, this is Jeremy Shulman, Network Automaniac on Twitter, and today I'm going to cover the topic of generators in Python, and I'm also going to cover the topic of iterators because they're closely related. Now I'm going to show you two motivating use cases that we're going to use here. The first is, as a network engineer, you might want to convert a MAC address from one format to another. So let's say that you have a MAC address, and I've got these, a MAC address in this form, and I want to change the format to be colon separated in groups of 2 characters. So I'm just using a PyCharm here, and I'm going to run this program, and you can see that what pops out here is, characters in groups of 2 separated by a colon. And if I wanted to change that to, for example, separated by dash in groups of 4, I could run that again, and we can change the format there. So it's actually the same format. But if I wanted to, do something like this, dash dash dash, and change it around, you can see how this is used. So I'm going to show you how this, format MAC address function was written because it uses some forms of iteration. So that's kind of the one use case that I want to cover. And the other use case I want to cover is a piece of code that was taken from a Netbox inventory generator. And there was a piece of code where I was looking at the device fields and I was augmenting the OS name with a flavor, so to speak. So if we look at this mock data, let's say I have a spine and its OS name is NXOS. And in the device tags for that record, I had a tag called platform flavor. And the reason why I have this is because I'm trying to account for the differences between whether or not a device has API access or if I have to SSH to the device and screen scrape it. So for the sake of argument, let's just say that platform flavor is used so that I can get the result of an OS name augmented with the platform flavor. Maybe this would be a platform flavor differently, not just SSH, maybe some other value, which I'll show you. So here we have a spine and we have a leaf. This leaf does not have a platform flavor value. And I'm going to just kind of run this really quickly. I'm going to iterate between both of those records and just kind of print out some results. So we will do that. And you can see that the leaf, just uses the OS name as is, and the spine uses the OS name augmented with the value of the platform flavor. So if I wanted to change this to, for example, maybe I wanted to do it the other way around. Maybe this is NXAPI. I could run this and you could see that, now I have NXOS, NXAPI. And in this case, if I added a tag here and I said, platform flavor is equal to SSH. Now we have, NXOS, SSH, and NXOS, NXAPI. So, the piece of code that we're going to go through is how does this thing work here where I'm pulling out the value and augmenting the OS name value with the flavor value. So those are the two use cases that we're going to cover in this tutorial. Okay, so let's go back to the first one. So before we get into actually exploring this piece of code, we're going to cover the topics of what is an iterator, what is a generator, and understand the mechanics of how Python treats each of those different things through iteration. So what I'm going to do is I'm going to pop open my Python console here. I'm going to make this a little bit bigger. You can see it. We don't need this here. Oops. We don't need the watch variables. Okay. So what we're going to do here is, let's see if this shows up okay. Hello. All right. So if you want to know what the type of a variable is, for example, we'll just say text is hello. We can say, well, what is this type? Or what is the type of text? We can see that that is a string. Now, a string is iterable, meaning that we can loop over its contents because it is made up of characters. So I could say for ch in text print ch, and you can see that it's printing out the HELLO, right? Because it is an iterable variable. We can loop over it. Generally speaking, we see things that are iterable like a list, like names is equal to Bob and Alice, and we would say for name in names print name. So we're looping over an iterable this list. So let's kind of take a step back and kind of look at what an iterable is and what an iterator is. And Python gives us a way to tell us what things are from a library called collections. And in here there are three things that we're going to look at. One is called an iterable. Another thing is called an iterator. And we're going to also use generators here in a minute. So we can look at names, for example, and we can see that the type of names is a list. And then we can ask Python whether or not names is an iterator. So I could say, is instance names iterator? And it says false. It's not an iterator. And you're like, that's weird, but I can iterate over it. And so if we said, well, is it iterable? It is true. So an iterator is a noun. It is a thing. It is, iterable is an adjective. Is that something that could be made into an iterator? So just to be complete, we could say is instance of names a generator, and it's going to say false. We'll get to generators in a minute. So you're probably scratching your head, well, what's the difference between an iterator and is something iterable? Again, names is a list, and it is iterable because we could do a for loop over it. So let's understand what Python is really doing under the hood there. There's a built-in function called iter. And if we said, given this variable names, I want the iterator for that thing, names. And here you can see that what this iter function does is it returns an instance of list iterator. So if I called this, if I save this to a variable called names iter, and I said, what is the type of names iter? It is a list generator. And if I said, is this instance of names iter an iterator? Now it's true, right? It's still iterable, right? Because I can loop over the contents of this thing. And is it a generator? It is not a generator. So iter is a built-in function that says, for a given instance, give me the iterator for that thing. And again, this is built in to the looping construct. So when you say for name in names, what Python is really doing is it's first getting the iterator for this variable, and then it's looping over it. So let's talk about the looping over it part. So if I have an iterator, what can I do with it? Well, I can ask for the next thing in it. So the first, what comes out is, in the case of a list, an ordered sequence. So the first thing out of that list is Bob. And then next thing out of that list is Alice. And then, now we're done. Stop iteration. So this is an exception called stop iteration. And this is how the for loop works. It is going through each of the items in the iterator until it reaches this stop iteration problem. So what's interesting about next as a function is it allows you to pass in an iterator, and you can also alternatively or additionally give it a default value. So what that means is if I ask for a default value, or if I ask for the next thing out of an iterator and there is nothing left, then return back this default value. So we can go through that same use case again where I say names. Well, the other thing that you should note from this is that when you consume an iterator, it is exhausted. Meaning if I said names iter, the variable is still there, but because it's been exhausted, meaning I've consumed everything, I'm always going to get stop iteration. Now, names is a list, and so I could loop over this many, many times. I could, say for name in names, print name again, because each time that for loop is run, the iter is getting created. The iterator for names is being created. So it's creating a new iterator, it's looping through that iterator, and then it's done, and I can repeat the process. But if I snap a variable to that iterator, again, if I say names iter is now iter names, I've got a new instance of that iterator, right? Because you can tell by this number, it's a new instance, whereas if I scroll back here, the number is different. And again, I could do the next thing. So if I said next names iter, and this time I give it a default of none, I can see Bob, I can see Alice, and now I got none. There's none here. If I see, Val is none, true. So if the trick here is if you pass next with the default value of none, then you won't get an exception, you'll just get the value of none back. Okay, so how do we see this in practice? For example, if I have the range function, right? Range, let me scroll back to the top here. Range gives you a range object that gives you numbers where you have a start, stop, and a step. So if I had range, say, for example, 1 to 24, what this is, it's a range type. And again, if I said, is this a iterator, it's false, right? I can't run next on this. It'll say it's not an iterator. But if I did iter this, it gives me a range iterator, then I could actually get the next. So again, if I was doing, for num in range, we'll just do like, 1 to 10, print num, you can see that it starts at 1, it stops at 10, does not include 10. That's kind of a little pitfall of using range. You always have to give it like the n+1. But you can see that, again, what Python is doing is it's saying, I have this object range, I'm going to get its iterator, and then I'm going to loop through that until I exhaust it through the stop iteration exception. Okay, so that's a little bit about iterators and something that is iterable. So let's talk about generators. Generators you will see in a couple of different forms. I'm going to only talk about one of the forms that I'm going to use in my my sample. And so let's start with how to create a generator in this particular case. Now, if I wanted to have, say, a list of numbers, and I said the list of numbers is 1, 2, 3, 4, and 5, and I said, well, what is the type of this numbers? I can see that it's a tuple, right? Is instance numbers iterator? Nope. Right? But if I wanted to get an iter of numbers, again, I'm just doing the same thing, we can see that this is a tuple iterator, right? So again, doing the for num in numbers, print num, it's going to go through those numbers. Great. Okay. What if you saw this? Numbers is equal to x for x in 1, 2, 3, 4, 5. What is numbers? Numbers is a generator. And now you're going, well, what is a generator? So if I said, is instance numbers iterator, okay, so it means that this is something that I could iterate over. Is it iterable? That's true. And is it a generator? So this is in fact a generator. And this is different than if I were to do, numbers is equal to square brackets, which is a list comprehension. So x in, for x in 1, 2, 3, 4, 5. So that's a list. But if I change this to parentheses, it's a generator. Okay. And just to be kind of interesting and complete, if I use squirrely braces, then this is a set, right? And all these things are used differently. Sets and lists and generators are treated differently for different purposes. But we're going to focus on the generator use case. So what happens is if I have numbers and it's a generator, can I do next on numbers? Well, it turns out that I can, right? I don't have to ask for an iterator. It's just going to give me, the next value. So that's an interesting characteristic of a generator, that the thing itself is an iterator, right, as I showed, and we can start using next. Okay, so what if we had essentially an if statement attached into this compression? Because again, what I'm building here is a generator, but it's a compression. I'm doing something inside these parentheses that creates the generator. And as a result, I could put an if statement in here. I could say only use x if, for example, x is greater than 3. Now again, numbers is a generator, so it didn't return me what it is. It's just a generator. And so if I said next on numbers, what it's going to give me is the value, the first value that is greater than 3, right? And if I do next again, that would be 5. If I do next again, I get stop iteration. Okay, so let's kind of do this example again, but change some of the values. So let's do 4, and then 2, and then 7, and then 1, and then 5. Okay, so now I could say, next numbers, and I get 4, and then I get 7, and I get 5, and I get stop iteration. That makes sense because I'm only asking for the values that are greater than 3. Now if you're looking at this and going, well, this looks like I'm doing something with a filter. It's true. It is very similar to using a filter with Python, except you're not using the filter function, but I'll show you kind of the filter method for that, right? So we could do the same. Well, I won't do that. Let's just kind of keep on the generators thing. So hopefully this kind of makes sense. Now, what would happen if, there wasn't a value greater than this? So let's say that this value was 10. So I have a generator, and if I say next numbers, there was no value greater than 10. Okay? So if I said next numbers and then none, I'll snap this to a variable, I can see that val is true. It is none, right? So value is none. So this is a technique to look at some values and then determine, I'm filtering for some values, and I want to find the first something in that list of values. And if I don't find it, I'm going to get none, and if I do find it, I'm going to get some value, right? So if I change this back to greater than 4, and I said, val is equal to next numbers none, and val, it turns out, is 7. Okay, so this is an interesting property of generators. I could say, give me the first thing. If I'm only interested in finding one thing, I could say, just give me the next thing that meets some criteria, and then if I don't find it, return none. Don't generate an exception. So with that in mind, let's look at our demo generator piece of code here. And so what you're seeing is I'm going to loop through a list of tags, these values. And so you're seeing this next, you're seeing this me use next here. And I'm creating a generator, right? So this is a generator because you can see the parentheses here. All right, you can see how they're matched up. And what I'm doing is I'm iterating for every tag in this device field of tags. I'm looking for a tag that starts with the string platform flavor. And when that's found, what I'm doing is I'm extracting the value. So I'm saying from that tag, split the string by the equal sign, give me the right-hand side of the equal sign. And that's my generator. And so from that generator, I'm saying, give me the next item in that generator. And then if there wasn't anything found, then flavor is going to be set to none. Okay, so just going back to this example where I'll say leaf doesn't have a platform flavor. You can see that, you know, there's not going to be a flavor added here. Now, the next bit of this is well, what's going on with this, what's called the Walrus operator? And this is really only found in Python 3.8. So what's happening here is the flavor variable is being set to the result of this clause. So flavor is going to be set to either a value or none. And because it's inside this conditional, then this piece of code is only going to get executed when flavor is not none. So I could have written this, you know, if I wasn't using Python 3.8, the way you would go about writing this would be flavor is equal to this, and then you'd say if flavor, you know. So that is the equivalent of the same function prior to 3.8. You can kind of see that here. So, you know, the way that the Walrus operator works is it works only within these clauses, you know, for example, like if. Just like that. So it's basically just a way to compress those two lines. So we're back here. So, you know, this is the way, you know, I use generators a lot, kind of in this pattern, which is to say, you know, I'm looking for something in a collection of data, and as soon as I find the first thing, then I might want to do something with it. So this is such a common pattern that there's actually a package out there called first, which I use quite a bit. So if you, I'm gonna install that inside my, I'm gonna install first really quickly inside of PyCharm. So I'm gonna click install. You can't see, it's not sharing the kind of the pop-up here, but I'm just installing a package called first. And just to kind of show how that works is I'm gonna comment this bit out here, and I could do something, actually, you know what? I could do it inside of my Python console here. I could say from first, import first. So if I said first and then gave it the numbers 1, you know, 2, 3, it's going to give me 1. And if I wanted to say, you know, x for x in 1, 2, 3, if x is greater than, you know, 5, found, I could see that found is none, right? Found is none is true. But if I said, you know, 7, 12, 19, 2, I have found a 7. So the interesting thing about first as a package is it handles that case of, you know, next something comma none for you. And it also handles what, you know, if something is either an iterator or an iterable. So I could say, you know, first could say, you know, first, I can give it a bracket, right? So that's just gonna, it's basically going to do the, turn it into an iterator and then give me the first thing in it. Or I could have done the same thing with, you know, like you saw here, you know, first, and then I'm giving it essentially a generator or a list of iterables, if you want to think about it that way. So first is a package that I use a lot for finding things. Okay, so that's generators. You know, if you Google generators, you're usually going to see something talking about a function that has a yield in it, and that is a very common use, but it wasn't the use case that I wanted to cover here because there's a lot of material that, you know, covers that particular use case online. All right, so that was generators. Let's go back to this particular example. How did we go about, you know, formatting, you know, anything to anything with MAC address? Okay, so let's go back to you know, the range function for a moment. So I have range, and range, I can say, you know, I want to loop 0 to 12, you know, for x in range, print x, and you know, you get your numbers, you know, 0 through 12. Well, let's say that what you really want to do is you want to kind of skip chunks, right? So let's just start with something a little bit simpler. Let's say this MAC address is this variable, but let me take out these dashes. Let's just make it just the flat characters. Okay, so we have this MAC adder. Let me make that a little bigger. Okay, MAC adder, right? So I could ask for MAC adder, and I said, well, I want the first 3 characters, or I could say I want the first 4 characters, right? If you haven't seen this notation before, this is what's called a slice, right? You just give it a start and an end, like we did before. You know, I could say, for example, you know, 4 to 7, right? So you can see, you know, I'm taking the 4th character and I end at the 7th character. I'll make this a little bit bigger. So how can I use range and this slicing mechanism together? Well, if I said range 0 to 12, and I want to say make chunks of, say, 3 characters, you can do a skip, right? This is every other number, you know, by this skip. So if I said for x in this, print x, now you're seeing 0, 3, 6, 9. So this essentially gives me my chunking, a way to do chunking. So let's say that I said I want my size to be 3. I want to break up my MAC address into groups of 3. Well, then what I could do is I could say, you know, for x in range 0 to 12, for every 3rd character in this case, I could do print MAC adder, and then I'm going to say x, comma, x plus size. So that's going to be, you know, kind of the chunk, and then the size of the chunk. Oops. What did I do wrong? Oh, sorry. It has to be a slice colon. So you can see that I've broken up that string into 4 chunks, the size of which is 3. Remember, this is 3. Okay, so rather than, you know, printing that out, let's just say that I want to collect those up, right? So let's say that I wanted to make something called chunks is equal to, you know, MAC adder, you know, that kind of thing, you know, for x in range 0 to 12 for chunk size. Oops, chunk size is 3. I must have just not done that variable. Okay, so now I've got chunks. So now you can see I've chunked it up into size of 3, and if I say chunk size is equal to 6, I've got chunks. You can see that, oops. Oh, I have this variable wrong, so let me fix that, because there we go. So now I've got, you know, 2 chunks of 6. It's important you get your variables right. And now if I wanted to join those chunks, with a separator, for example, if I wanted to do a dash, I could say join these chunks, and you can see that it's joined those chunks with a separator. So if I had a separator is equal to dash, then I would say sep join chunks, right? So now if we put this all together, I could say sep join, and I don't even need I don't need to make a list of things because, I don't need to make a list of things because join takes an iterable. So I could say sep join, don't need that bracket, and I do need to make this ch size, and I don't need to make this here. And actually, it's not chunks anymore. This is, new Mac adder. In fact, I won't save it to a variable. We'll just print it out to the screen. So you can see now, that's just printing out, the return value of that operation. And if I wanted to say chunk size is equal to 2, I can see that I've broken it up. And if I say sep is equal to, say a colon, break it up into colons. So, putting all that together, that's how we can take, a MAC address, of a given, 12 characters, and then chunk it and separate it, in any way we want, using the construct of this is an iterator, and join takes essentially a sequence. So this is building a sequence in line to do that. So the only thing left really is well, how do we, get rid of the things that are not, characters, right? If we only want to use, valid MAC address characters, the way we go about doing this is we would use the regular expression package, and we could say, find all values that are A to F and 0 to 9. And we don't really care about the case. And if I took a test value of this value here, so essentially it's finding all the characters, that match that. So it's kind of stripped out, if you will, these dashes, or essentially anything that isn't a valid MAC address character. And if I wanted to put those all back together, into a single value, I could do that same join trick. I could say, just characters is equal to this, and just characters are now that. So to go from any format to any other format, it's kind of a two-step process. We're going to take the given string, we'll find, all the correct characters, and we'll turn it back into a single flat string using this this join. And then we can use that other trick, to put it all back together in another way. And so what that looks like, if you look at the code, it looks just like this. So take the just characters, find everything that is a valid MAC address, ignore the case, and then return the join through that process. So hopefully that was, a bit of interesting, bits and pieces of Python, learning how iterators work and learning how one pattern for use with a generator. If you have any questions, please drop them at the bottom of this video. I'm happy to answer. All right, thanks.